Right, quite. So today we will discuss the lesson atoms. Name of the lesson will be atoms. In this atoms lesson, totally, if you observe, here atoms lesson total marks will be 6. How many marks are coming from this means 6, and one mark question one will come, 5 marks theory question one will come. Totally 6 marks from this chapter. How many marks are there means this will be 6 marks. Okay. Now we'll start go with the topics. Just 3 5 marks questions are there. Repeatedly in that only they are asking the questions. Okay. So what are the questions? See what are the questions they are asking. See the first question. Write 3 postulates of Bohr. Mention 2 limitations of Bohr atomic model. 3 postulates 3 marks. 2 limitations 2 marks. Okay. Same question. All are in different years. They are asking in this format. So 3 postulates will be 3 marks. Limitations, any 2 limitations will be enough, that is 2 marks. Like this it will be there. Now yes, see what is the answer for this. Bohr's postulates electron can revolve around the nucleus in a certain stable circular orbit without the emission of energy. So, without the emission of energy, see the first postulate, what it is, electron can revolve around the nucleus in certain stable circular orbits without emission of energy. So, electrons are revolving around the nucleus in circular orbits. These orbits are called as the stationary orbits. Next, see the second one, what they are asking. Electron can revolve only in those circular orbits in which its angular momentum is integral multiples of h by 2 pi. So electrons are revolving in the circular orbits without any emission of the energy. That will be first one. Second one, electrons are revolving in the circular orbits. The angular momentum of the electron, this value will be equal to here h by 2 pi, L is equal to nh by 2 pi, or mvr is equal to nh by 2 pi. That is the second one. Next, after this, see the third one. Here L is equal to nh by 2 pi. Next, next third one. An electron can move, can make a transition from higher energy orbit to lower energy orbit. In this process, photon is emitted having energy equal to the energy difference of the initial and final states. So h nu is equal to, this value is equal to E2 minus E1. Okay. That is energy third law. So totally three laws are there. What are that? See, electrons can revolve around the nucleus in certain orbits. Like this is not going. Madam, I will call back you. I am in class. Next, see the second one. What are the limitations? It is applicable to hydrogen atom. It is applicable only to the hydrogen atom. Okay. It cannot extend to two or more electrons. So it is applicable to only, I will open this. 1 minute, we'll do this one. So that is, this is the first question. It is applicable to only hydrogen atom. So okay, see here. What is the second means? It does not tell anything about the relative intensity of the, so it is not saying anything about the relative intensity of the various spectral lines. Okay, that is the second one. It does not explain the linear structure of spectral lines in the hydrogen atom. It does not explain Zeeman effect and Strock effect. So this is the first question. So what is the first question? Energy. No. What, write the three postulates of the Bohr. This will be 3 marks. Write the three postulates of the Bohr will be 3 marks. Mention two limitations of Bohr's atomic model. It will be 2 marks. So combinedly it will be 5 marks question. Already you prepared this question. Then my suggestion is remember the questions. That is enough. Okay. So what is the, just you note down this question. That is enough. Already the terminology what is here used here, the terminology what you prepared, there may be a difference. That's why what I am suggesting is just remember that questions. Write three postulates of the Bohr. Mention two limitations of the Bohr's atomic model. That will be 5 marks question. Next, see the second question, what they are asking. So this will be energy of the electron in the stationary state of a hydrogen atom, assuming expression for the radius. So you have to derive an expression for energy stored. So what is the expression for total energy of an electron? And using, considering the expression for the radius. This question may be asked like this also. Assuming the expression for radius of the orbit, derive an expression for total energy of an electron. So what is the second question? Expression for total energy of an electron. by considering the radius of the electron, radius of that orbit. Okay. Next, or it can be asked like this: derive an expression for the energy of an electron in the nth stationary orbit of hydrogen atom by assuming the expression for radius. In any manner, they will ask this question. Whatever it may be the question format, what they are asking is derive an expression for energy of electron in the nth orbit. So, okay. In these three formats, this question may be asked. Already you prepared this question. This question is asking in this format that I want to tell. Already here some notes is given. You prepare in your style already how you prepared. In that manner, you prepare this one. Okay. So that is about the second question. So if somebody is still not prepared, then go with this. Already, if you prepared, then you stick with that. If you are not prepared up to now, then you go with this. We are providing the notes also. So finally, what is the expression for the energy of the electron by considering the radius En is equal to this value z square e power 4 m by 8 epsilon naught square h square n square. If we consider for the hydrogen atom, then what we will get? Z value will be equal to 1 for the hydrogen atom. So it becomes minus e power 4 m by 8 epsilon naught square h square n square. Okay, what you had to remember from this chapter, totally 6 marks are coming. In that 6 marks, one mark question will be there, one 5 marks question will be there. 5 marks theory questions, 3 are there. What are that? First question, 3 postulates of the Bohr and 2 limitations of the Bohr's atomic model. That is one question. Second question, energy of the electron, total energy of the electron in the nth orbit. In the same way, energy of the hydrogen atom. Like that, questions will be there. Next, see the third question, radius, expression for radius. Derive using Bohr's postulates. Derive the expression for the radius of nth stationary orbit and expression for Bohr radius. This will be 4 marks, this will be 1 mark, totally 5 marks. Okay. So for this also already explanation is there, you check it. Finally, R value will be radius of the electron in the nth orbit. Rn is equal to n square h square epsilon naught by z e square pi m. That will be the radius. Bohr's radius means you have to take n is equal to 1. So this will becomes as Rn is equal to h square, n value will be 1 here. So that's why it becomes h square epsilon naught by z value is also 1 because hydrogen atom, n value is 1. So h square epsilon naught square by e square pi m. So totally how many 3 marks questions are there means 3. What is the first one? 3 postulates and limitations. 3 postulates of the Bohr and limitations. Next, second question, expression for total energy of an electron in the nth orbit. Next, expression for radius of the electron in the nth orbit. Next, expression for Bohr's radius. These 3 questions are there. I think all of you prepared these questions. Just I am once again saying the questions, that's it. Already what you prepared, you continue that preparation. Still not prepared, then you go with this. Okay. Next, 3 marks question means there is a chance of asking 3 marks and 2 marks combinedly as a 5 marks question. So derive an expression for the velocity of an electron revolving round the nucleus of hydrogen atom. Expression for the velocity of the electron. So second law, we will take second postulates. From that V value we will write and R value by substituting. Finally, we are getting this one. So how much we are getting here is velocity of the electron in the nth orbit. Vn is equal to Z square 2 epsilon naught nh. If we consider the hydrogen atom, then for hydrogen atom, Z is equal to 1. So its velocity value will be E square by 2 epsilon naught nh. That will be the formula for it. Okay. So 3 5 marks questions, one 3 marks question. These are enough. Already they mentioned no 2 marks question will be asked in this chapter. But benefit of doubt, only one question, 2 marks question from this it is asked in the previous chapter, previous question papers. From the past 14 papers, only one time, one 2 mark question is asked. So draw the diagram representing the schematic arrangement of Geiger-Marsden's experiment. Geiger-Marsden's experimental setup. For this, draw the diagram or Rutherford's alpha scattering experiment. It will be also called as draw the setup. So see here how it will be there. Here source of alpha particles will be there. These alpha particles are incidenting on the lead bricks. From that fine beam of narrow beam of alpha particles are coming. Source of alpha particles. From this they are incidenting on the lead bricks. Then fine beam of alpha particles are coming. They are incidenting on the gold foil. This will be gold foil. This will be. Then some are scattering. Those are incidenting on the zinc sulfide screen. Here, microscope is there. We will observe that scattered radiation on the screen with the help of the microscope. This will be gold foil. These are scattered rays incidenting on the zinc sulfide screen. This will be detector or microscope. These are lead bricks, source of alpha particle, beam of alpha particle. Just these two are the two supports to hold this. Blocks are there, square blocks. Those are just supports. They are holding the gold foil. Okay, this is Geiger-Marsden's experimental setup, or we can consider it as the Rutherford's alpha ray scattering. Next, one more questions, just 4 are there. You prepare this, my guess from this chapter, only on the spectral lines there is a chance of asking the question. Name the spectral series of hydrogen which lies in the ultraviolet region of the electromagnetic spectrum. Must see here, totally 5 series are there. What are that? Lyman. Next one will be Bomber. Third one will be Passion. Next, fourth one will be Bracket. Fifth one will be Fund series, Lyman series. Bomber series, fashion series, bracket series, fund series. Okay. Lyman series will lie in the, it will lies in the ultraviolet region. Bomber series will lies in the visible region. UV, you can remember, this will be near infrared region. Next, this will be middle infrared region. This will be far infrared region. Am I understanding? So Lyman series will lie in the, what is the first question? See, name the spectral line of hydrogen which lies in the ultraviolet region. Ultraviolet region, what is there means? That will be equal to, wait 1 minute. Yes. So in the ultraviolet region, what are there means Lyman series is there. Lyman series, here we explain, here see. Lyman series, it will be ultraviolet region. Next, second question, name the spectral series of hydrogen atom in the visible region. Name the spectral series which lies in the visible region of electromagnetic spectrum, or name the spectral series of hydrogen atom which lies in the visible region of electromagnetic spectrum. So answer will be Balmer series. And see here, here UV region. Wait. Here went these are. This will be visible region. This will be near infrared. This will be middle infrared. This will be far infrared. Okay. So visible region means it will be Balmer series. So this is the answer for it. Balmer series. It lies in the visible region. Okay. Answer for the second question will be Balmer series. Next, write the expression for energy of an electron or bit in the hydrogen atom. Already formula we know, En is equal to E power m 8 epsilon naught square h square n square. Okay. So this is the, once again we'll draw. Energy of the electron in the electron hydrogen atom, that's value will be E power 4 into m by minus 8 epsilon naught square h square n square. Next, name the spectral series of hydrogen atom in the infrared region of the electromagnetic spectrum. Passion series will be there, bracket series will be there, fund series will be there. All are lying in the infrared region. Passion will be near infrared, bracket will be middle infrared, fund will be far infrared. So all these are lying in the um, infrared regions. So, infrared region, which series is lying? Only three series: ultraviolet, Lyman, visible bomber. Remaining three will be infrared. Okay, these questions are enough in this chapter. You prepare thoroughly all of this. So, totally from the atoms chapter, you see atoms in this chapter. One mark here, 1 mark questions are there. These are 2 marks questions. These are 3 marks question. Is 5 marks theory. This is 5 marks problem. So in this chapter, 1 5 marks theory and 1 1 mark will come. Whereas in the dual nature, you have to concentrate on the problems. In the atoms, you have to concentrate on the three theory questions and 1 mark questions. My guess, totally 1 mark question they will ask on the spectral lines. Okay. So any doubts are there, you call me, because all these are, if we are explaining on the board now, for writing and everything, it is taking more time because already everything is ready made. Just you are listening. That's why this class will complete in half an hour maximum. So I will finish this class now. I will close this class. I will share these notes for you, all of you. Any doubts are there? Still, after atoms, how many lessons are there? Atoms, nuclei, semiconductor devices. We'll finish the 2 chapters also like this, and after that we will plan what to do. Okay. Okay. Now I am closing this session now. Any doubts are there? Please feel free to call me. I'm ready to explain all of your doubts. Okay. Thank you. Bye, Ra. Bye, bye, Ra. For writing on the board, some students are feeling difficult, ma. That's why. For see here, Tejaswini, what's happening is for typing and preparing all of this, it is taking more time. And for board, actually, it is convenient for me. But so many students are not writing what I am writing on the board. Like you, some 5 to 10 students writing. Simply they are listening and going. That's why I felt like this. We'll see. Monday we'll go with the board. What will happen? We'll respect your opinion also. Will Monday we'll go with the board. వాట్రా రాంబాబు ప్రీతం నీ ముఖం వీడియోలు తయారు చేస్తా కూర్చున్నా ఇంద్ర సన్నాసి ఓకే 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 ఐ విల్ క్లోజ్ ది సెషన్